Assalamualaikum warahmatullahi wabarakatuh and very good afternoon. I am Muhammad Ikhwan bin Roslim with my final year project titled Optimization of 3D Printing Parameter for Die Curving. Without further ado, let's go to the next slide. Batik curving use the technique of die curving. Current batik printing is operated manually, which needs skilled worker in coloring the batik. This project is to improve the productivity of batik printing industry in Malaysia. Problem statement. The commercial batik coloring process has many drawbacks such as low efficiency, low production and lack of skilled craftsmen. Manual die coloring process in batik industry is time consuming, which limit the production of the batik textile. Next, the objective of this study is to investigate the current batik die coloring process, to develop modular-based liquid extruder for die coloring using FDM 3D printer, which is a fused deposition modeling 3D printer, and finally, to optimize the parameter for 3D printing die coloring using the algorithm of a 3D printer. The scope of the study is only focused on the coloring process of the batik. The SnapMaker desktop 3D printer will be utilized in the study for the automated coloring trajectory. This part will show the flowchart of the study, which will start with the background study, design sketching, 3D modeling and concept selection, and finally, the fabrication of the ink reservoir or the modular-based die coloring. And finally, we'll be running the testing or optimization planning and validation test and end the study. This is the modified SnapMaker desktop 3D printer that being utilized throughout this project to run all the optimization parameter tests. This is the 3D printed ink reservoir that have been chosen through selection to be used throughout this project. Result and discussion. For optimization plan, orthogonal array L934 is used to run series of experiments in order to obtain the optimized parameter. Orthogonal array L934 stands for 9 number of experiments, 3 level, and 4 factors. The model used for the experiment is a 30 by 10 mm rectangular, which have been transformed to STL file. The factors that will be considered are the nozzle type, which is the needle size, line width, travel speed, and retraction. These are the list of the parameters and number of tests that will be used throughout this project. Parameter that being considered is the nozzle diameter, layer height, travel speed, and retraction. Experimental factor and factor level. For this project, there are 4 control factors with 3 factor level, which is the control factor. First is the nozzle type, second line width, third the travel speed, and finally the retraction. Orthogonal array of the experimental run. This is the table that has been used as reference to run all the tests in this project. For the first scoring is based on the size of the ink spreading on the batik cloth. The score is based on for 1 point 4,501 mm² until 6,500 mm². For 2 points 3,501 mm² until 4,500 mm², and the highest score is 3, which is 0 mm² until 3,500 mm². For each experiment, the experiment is run multiple times and the top 3 or the best 3 will be chosen for the scoring. This is due to get the average point for each experiment. From this response table for size criteria, you can see that factor A rank for number 1, factor D rank for number 2, factor C rank to number 3, and finally the factor B rank number 4. From this response table, we can get the PV value using the PV equation, and from this we can get the optimized parameter, which is for the factor A level 2, factor B level 1, factor C level 1, and finally the factor D level 1. This is a video of the validation experiment for size. For the next criteria is the ink residue. The ink residue is the ink collected after the printing finished. For the score, the 1 point is 2.6 milliliter until 3.5 milliliter. The number 2 points is 1.6 milliliter until 2.5 milliliter. And the 3 point is 0 milliliter until 1.5 milliliter. For this experiment, each experiment also run multiple times, and 3 will be chosen for average amount. This is the response table for the ink residue. From this table we can see that only factor C is not significant in this experiment, and factor C is being ranked number 4, while A is being ranked first. Factor B and D ranked second because of two of them give the same amount of the difference. Finally, we can go for the recommendation in ink residue using the PV value. And finally, we can get the optimized parameter, which is the factor A level 2, factor B level 1, factor C level 2, and factor D level 1. As you can see, these are two batik cloth for the validation experiments. These are the sample of the printed cloth running throughout this project for the 9 experiments and been done in multiple times in order to gain the average amount. Objective versus conclusion. First, the objective is to investigate the current batik die curing process. From this project and from the literature review, I can conclude that manual hand coloring by craftsmen are the most well known in the batik coloring process. Second, to develop the modular-based liquid extruder for die coloring using the fused deposition modeling 3D printer, I can conclude that the ink reservoir that has been used for this project is printed using the FDM 3D printer. And finally, the objective to optimize the parameter for 3D printing die coloring using the algorithm of a 3D printer. I can conclude that the new algorithm that have been written to print out the die coloring using the SnapMaker desktop 3D printer auto generation algorithm. For the final part is the recommendation. Firstly, a new algorithm needs to be written for further study in order to print liquid die coloring smoothly and without any failure that will affect the quality of the printed cloth. And finally, in order to overcome any uncontrollable variable, a new ink reservoir or extruder need to be developed in order to make any printed cloth will be high quality. This is all from me. Thank you.